Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 7, 2025, about 6 days ago. This paper introduces a technique that boosts a model's accuracy by over 5% on a key benchmark, all without needing any new labeled data. The paper is titled Test Time Reinforcement Learning for GUI Grounding via Region Consistency. And it's a fascinating look at how models can essentially teach themselves to get better during inference. The work focuses on a task called Graphical User Interface Grounding, which is the challenge of accurately linking a natural language command, like click the profile icon, to the precise coordinates on a screen. Also, the authors shared their implementation on GitHub, and it's quite complete. You'll find the code for both the region consistency voting and the policy optimization methods they developed. It includes setup instructions and the scripts you'll need to run the evaluations and training on your own data. Alright, so this figure gives a great visual overview of the two core methods. The top part shows the first method, GUI-RC. Instead of one guess, the model makes several predictions. These predictions overlap, and the area with the most overlap, the consensus region, becomes the final, more accurate answer. The bottom part illustrates the second method, GUI-RCPO. It uses that same consensus idea to create a reward signal, which then fine-tunes the model's parameters during inference, all without needing any new labels. Moving on to the results, this table details the performance boost from using the GUI-RC method. You can see consistent improvements across various models and benchmarks. For example, the OS Atlas Base 7b model gets an overall lift of 2.75%, with a notable 6.28% increase in icon localization. Another key finding is that models predicting bounding boxes benefit more than those predicting single points, likely because the boxes provide better initial region information for building consensus. This table then details the results for GUI-RCPO, the reinforcement learning method. The improvements here are even more substantial, with gains of 4 to 5% on average. For instance, the QN 2.5 VL3B instruct model jumps from 80.11% to 85.14% on the ScreenSpot V2 average, a lift of over 5%. This demonstrates how using the region consistency score as a reward signal allows the model to effectively teach itself and surpass the simpler voting method. Digging a bit deeper, these plots show an ablation study, which basically tests how tweaking different settings affects performance. The charts explore three key parameters: temperature, sampling number, and a hyperparameter called expand size alpha. For temperature, we see accuracy peaks around 0.5 before dropping off. Too much randomness hurts. Similarly, for sampling number, performance improves and then plateaus. More samples help, but with diminishing returns. Finally, expand size alpha also has a clear sweet spot around 50, showing that these settings need to be just right. Now, looking at the training process itself, these plots track the performance of two different models using the region consistency policy optimization method. We can see the accuracy for both models. The QN 2.5 VL7B and the 3B steadily improves across all three benchmarks as training progresses. The performance generally converges after about 80 steps. Importantly, this shows robust generalization, since the models improve even on benchmarks they weren't explicitly trained on, like ScreenSpot Pro, without overfitting. Alright, to make this more concrete, these case studies show how the method fixes common model errors. On the left, we see the initial, single guess from the model, which is often wrong. For example, in the top left image, the model is told to find shoes under $50, but it mistakenly highlights tops under $25. Then on the right, after applying GUI-RC, the heat map visualizes the consensus from multiple samples, and the final green box correctly lands on the target element. So, as we've seen, this is a really clever way to improve GUI grounding without needing more labeled data. The core idea is that a model's own consensus, derived from multiple guesses, provides a powerful signal to correct errors and even to self-improve through reinforcement learning at test time. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.